Hey and welcome back. This is episode number 8 of this tutorial series / crash course on ROS Noetic. You can find the series playlist in the description. And let's get started. So in the previous tutorial you have written your first ROS publisher with Python. Now we're gonna go to the other side of the topic and you are going to write your first ROS subscriber. And we are still going to use Python here. So to create a subscriber, we need a topic, because we need to subscribe to a topic. So I'm gonna start the turtle sim node again and see what topics we can subscribe to. So let's use ROS core here, ROS master. So in any terminal, actually I always start it here, but you could start it in any terminal. ROS1, turtle sim, and let's start the turtle sim node that you start to know already. Great, so this turtle sim node here, we have the turtle on the screen, and I'm gonna do ROS topic list to see the different topics. Okay, so you can see we have 3 topics with the turtle sim node. As you already know, for example, command velocity is a topic that this node here is gonna subscribe to. Okay, so we wrote a publisher on that, and we are gonna use now the turtle1 pose topic. Okay, if I do ROS topic info turtle1 pose, you can see that we have a publisher which is the turtle sim. Okay, so nobody is subscribing for now. We're going to create a subscriber for that, and we have also the type here. So before you create a subscriber, you can already see what's going to be published with ROS topic echo and the name of the topic. So turtle1 pose, and you can see we have, so this is actually being published very fast. Okay, just always the same data because the turtle is not moving. Let's go back to info, and now let's write our subscriber. So let's do that here. Let's go to our source and then my robot controller and then script, and we're gonna add yet another node here, so yet another executable. Touch, let's call it pose subscriber. All right, it's here, and let's make it executable. Pose subscriber is green. Great. And I'm gonna go back to the source of the Catkin workspace and just open Visual Studio Code here. Okay, and we have the new file, which should be, well, that one. Great, so I'm gonna start by just initializing the node. Okay, so interpreter is Python 3 with ROS Noetic. We import ROS_by, and then if name is equal to main. The first thing we do, again, before we create any subscriber, is to do ROS_by dot init node, and we give a node, let's call it turtle pose subscriber. Okay, so as you can see here, I have chosen a different name for the node and for the executable. Great. And now what we need to do is to create a subscriber in this node. So I'm gonna create a subscriber. I'm gonna name it sub is equal to ROS_by dot subscriber. You can see we have a subscriber class. So we're gonna create a subscriber object, and basically the same way we have created a publisher here. As you can see, ROS_by dot publisher and ROS_by dot subscriber. Okay, quite simple. And then what do I need to give in the parentheses? First, the name of the topic. And then I will need to give the type. So this is the same thing. Okay, when you create a publisher, you give the name of the topic and the type. For a subscriber, you're gonna do the exact same thing. So what is the name of the topic? Let's go back to the terminal. The exact name of the topic is /turtle1/pose. Okay, if you try, for example, to listen to pose or to anything else, or if you forget the slash, well, you're just gonna receive nothing because this topic doesn't exist. We just use the exact same name. After that, we need to give a type. So what is the type of this topic? So what kind of messages are going to be sent? The messages are turtle sim pose, okay, that you can get with ROS topic info. So we're going to import the pose message from the turtle sim package, okay? And so here we are going to do from turtle sim, that's the name of the package, dot msg, okay, we're going to get a message import pose. And because we use turtle sim, we need to make sure it's in the package.xml, but as you can see, it is already here. So the dependency is already in the package.xml. We don't need to do anything else. So we come back to our node, and now we can provide pose here. Great. And now let's continue. So for the subscriber, we have name, type, and we need to provide a third argument. So here we're not going to provide a queue size, but we're going to do callback is equal to, and we are going to need to create a callback function. So why is that? Well, simply because the subscriber then is gonna listen to the topic. And when you receive a message from the topic, a callback function is gonna be called in your code so that you can process the message. And so we need to create a callback function. I'm gonna create it right here before the main def. And let's simply name it pose callback. Okay, so usually what I do for the callback functions is whatever you're gonna receive or do, and then the name callback, so that you know this is a callback function, so that you don't use it by mistake in your code. So I'm gonna open, close the parentheses, and what do we receive? We will receive a message, which is actually a pose. Okay, and let's do this. And well, what we're gonna simply do for now, and we're gonna improve the code later, I'm just gonna do rospy.loginfo, and we are just gonna print the message like that, so the complete structure. So that's the simpler callback you can do, is just to print what you receive, okay? And now we're gonna do pose callback, okay, without any parentheses here, okay? You just pass the name of the function to the callback parameter here. Great, so now we have the subscriber. Let's actually add let's put that here, and let's actually add a print here. So rospy.loginfo, let's say node has been started. We have initialized the node, we have a subscriber, and now we have a log. I'm gonna save this, and well, let's just try to run this code to see what's gonna happen for now. Okay, so I'm gonna go back to the terminal. We still have the turtle sim node running here, and here let's do cd and clear and ROS run. So ROS run my robots controller, and now if I press tab twice, you can see I have 3 executables. So pose subscriber. So let's look very carefully. Node has been started, and then, well, the node exits. So nothing happens. Why is that? Well, because that's exactly what you tell your program to do. Initialize the node, create a subscriber, print something, and then exit. So here we will need some kind of mechanism to keep the node alive and to also be able to process all the callbacks that we receive from all subscribers. So here we just have 1, but we could have many subscribers. So what you're gonna do, and you will see this is very common, you're gonna find that also in many nodes. You're gonna do rospy.spin. Okay, so what is rospy.spin? Well, spin, as you can see, is gonna block until the ROS node is shut down and yields activity to other threads. Means that this callback is actually gonna work in another thread. It's gonna be called in another thread. So this is kind of an infinite loop that's gonna continue. Okay, keep the program alive. And if you receive any message on this subscriber, for example, this callback is gonna be called in a different thread. And when you press Ctrl C, or if you kill the node, the ROS.spin is gonna exit, and well, everything is gonna be cleaned, and you're gonna exit the program. Okay, so if you can see you have two distinct structures here that are very common. This structure where you create a RAID and then you do an infinite while loop. So this one is more active. Okay, you're gonna do something every X hertz, and this structure here is more passive. Okay, ROS.spin, where you block the program and you allow it to process any callback. What you could do also is to create different threads here before ROS.spin, so you could do other actions, okay, in parallel, because once you do ROS.spin, usually that's the last line of your program, okay, and after the program is just gonna exit. Okay, so I'm just gonna save now, and let's go back to the terminal and let's run the node again. Okay, oh, it's working. So I'm gonna press Ctrl C now, and as you can see, if I go back to the beginning, well, we have a lot of logs. So node has been started, and then because of the ROS.spin, the node is gonna continue to work and is gonna receive and process all the messages in the callback. And you can see here we have a first callback and then a second one, etc., etc. And this is going very fast because, well, simply the publisher here on the TurtleSim node is publishing a lot of data. Now if I start again, so we still receive some messages. You can see the timestamp which is increasing. And now if I kill the TurtleSim node, as you can see, we don't receive anything. But so here I'm pressing enter. Okay, the node is still alive. Okay, as you can see, the node is still running. It's just not receiving and not processing any callback. If I start the TurtleSim again, you can see we continue to receive some messages. And actually now we can introspect this topic more to see the different nodes. So let's start it again. If I do RQT graph here, we have, so you have the TurtleSim node here, which is publishing to the Turtle1 post topic, and we have the TurtlePost subscriber, which is subscribing to this topic. So then the TurtleSim is sending some data to the post subscriber. And if you want to create any other node that will get this data, you just create another node, you just subscribe to Turtle1 post, and you're gonna receive also all the messages. And if we do here ROS topic info Turtle1 pose, you can see that now, so before we had one publisher and 0 subscriber, now we have one publisher, which is the same, and we also have a subscriber, which is the TurtlePost subscriber node. Okay, so you can actually introspect and see what's happening with ROS topic info, RQT graph, etc. And now I'm just gonna come back to the code because, well, this is, well, a lot of information and maybe we don't need everything. So let's say we just want, so when we process the callback, we just want to print the X and Y coordinates. Okay, so we have, you can see we have an X field, Y, and then theta, etc. We just want X and Y. So we're just gonna do that. So I'm gonna remove that and I'm just gonna say, okay, we're gonna start with a parenthesis like that. And then let's say we're gonna print msg.x. And as you can see here, we don't have auto-completion because, well, in a callback, this is actually more a Python thing, okay? Python doesn't know it's gonna be a pause. So what you can do to help is to just put colon and then pause. So this is not gonna do anything in the code, okay? That's not mandatory. It's not gonna add anything. It's just gonna make it more readable, okay, for you and other person to know that, yes, you're gonna receive a pause, and it's also gonna help for auto-completion and stuff like that. So now if I do msg dot, you can see I have angular velocity, linear velocity, theta, x, and y. Okay, and I'm just gonna cast this as a string so that we don't have an error. So we print this, and then let's put a comma, and then plus, let's print msg dot y, and plus, let's close the parentheses. Okay, so we just format the text in a different way, and we just get X and Y and nothing else. So in a callback here, in a subscriber callback, you can do actually everything you want. So you get the message, you can just print it, you can save some data here in the node to process it in a different thread, but for now we just print some data. So I'm gonna save the file and let's go back here. Let's run this and you can see now this is a much better view. Okay, we have X and Y coordinates. Now I am gonna, so let's do that here, ROS clear, and let's do ROS run turtle sim with turtle teleop key. So we're gonna move the turtle, okay, here. So make sure again you select this terminal and let's move the turtle. And when you move the turtle, you can see here the coordinates are moving directly. Okay, the X coordinates. So if I go back to close to 0, you can see, and then I'm at 0. And if I go close to the top, okay, I'm at the top with 11 something for Y. Okay, so you can see the coordinates directly on that node. And well, congratulations, you have written your first ROS subscriber with Python. Alright, that's the end of this episode. If you found it useful, you will definitely like my full course named ROS for Beginners. This course contains 6 hours of content and will teach you everything you need to create complete ROS applications. You can find the link in the description. Thank you for watching, see you in the course or in the next tutorial of the series.